Hey, everybody. How are you all doing? Welcome to
Hello.
Howdy. All right. So for those who are joining us for the first time, Howdy Partner is a weekly Twitch series where we highlight AWS Partner Network technology partners that have built innovative solutions validated by AWS solutions architects. So our show is designed to help the AWS cloud community, both experts and individuals new to the cloud, learn about how leveraging APN partner solutions can help your organization drive big results, better businesses, and just overall learn something new. All right. So today I'm joined by three new people here. So we have Mansi, who is going to be my co-host for today. We also have CircleCI represented by Angel and Kyle. So why don't you all go around and introduce yourselves for real quickly before we jump into things?
We'll let Mansi go first, yeah?
Yeah, of course. Hey, everyone. My name is Mansi. And similar to Braeden, I'm a partner solutions architect with AWS. I'm really excited to be here today talking about CI/CD with CircleCI.
I can go next. So my name is Angel Rivera. I think I'm a senior developer advocate now with CircleCI. So my role at CircleCI is to do things like this and engage with developers about technology, how they're using technology, concepts within technology such as continuous delivery, and then helping them either understand those technologies or helping them maybe get over some of their struggles with technologies, and then also bringing all those learnings back to our team at CircleCI so that we can incorporate those learnings into valuable features that we will then release to our customers and developers out there in the community. And I'm really excited to be here today to show off all the cool stuff that we're working on. Thanks for having us.
Awesome. Absolutely.
And my name is Kyle Tryon on the community and partner engineering team at CircleCI. What we're responsible for is building integrations and open source assets for CircleCI. So my team creates things called orbs, which is an integration for the CircleCI config, as well as we create a whole slew of Docker images that help people get up and developing on CircleCI easier. So we'll also do all the sample projects, anything that you might interact with. And I work very closely with Angel and his team to make sure those assets are spread out and talked about. And that's basically what we're doing here today. Also excited to be here. Thanks for having us.
Absolutely. Thank you for joining us. So, before we get kicked off into the great demo that CircleCI has for us, Mansi has actually prepared for us a nice introduction of what CircleCI's overall topic is about. So I'll go ahead and pass it off to you, Mansi.
Awesome. Thanks, Braeden. So yeah, I just wanted to first start off kind of by talking about what CI/CD is, defining it, and what it stands for. So CI/CD basically stands for continuous integration and continuous delivery. So let's dive a little bit deeper into each of those. So the first thing, so what is continuous integration? Well, it's basically a practice where developers are encouraged to integrate their code into a main branch of a shared repository early and often. And so instead of building out features in isolation and integrating them at the end of a deployment cycle, code is integrated with the shared repository by developers multiple times throughout the day. So what does this really look like? So basically, every developer commits daily to a shared mainline, and then every commit triggers an automated build and test. And if the build and test fails, then it's repaired pretty quickly, sometimes even within minutes. And so the big question here is, why do we want to do it this way? So first off, it improves team productivity and efficiency. So with consistency in the integration process, teams are a lot more likely to commit code changes more frequently, which can lead to better collaboration and software quality. And then it also closes the feedback loop when builds fail, because you're able to find problems and solve them pretty quickly. And then lastly, it also gives you the ability to release higher quality code that's more stable. And then, so that's basically continuous integration. And so continuous delivery picks up where continuous integration ends. So with continuous delivery, It automates the delivery of the applications to the selected infrastructure environments. And so generally, most teams work with multiple environments, like development and test, for example. So not everything is done in production. And so with continuous delivery, it basically ensures that there's an automated way to push these continuous code changes to those environments. And so the rationale behind this is that it's just easier to identify defects and other software quality issues on smaller code snippets instead of larger ones that are developed over a longer period of time. So you can catch any bugs or any issues that it creates right away. And so DevOps and CI/CD pipelines are really essential nowadays for not only code production and deployment, but also for things like infrastructure maintenance. And so starting from source control all the way to production-ready environments, CI/CD pipelines really are the bread and butter of modern application development. And like I mentioned earlier, they provide things like speed, deployment consistency, testability, and really just complete control on how the application is deployed. And this doesn't only have to be deployments on the cloud, but it can also be to on-premise locations. So that's basically what CI/CD is. And with that, I will hand it over to CircleCI.
All right, I guess that's us, Kyle. Thanks, Mansi, for that 101 on CI/CD, continuous delivery. That saved me from having to pull up my old slides and level set everyone. So yeah, like I said, we're excited to be here. And but today we wanted to demonstrate a few things. So we recently, at CircleCI, we recently added a few new features, or released a few new features that we're kind of going to show off today. And the theme of this discussion is going to be around microservices and monorepos, right? Like, how do you manage those things, or how could you manage those things within your CI/CD pipeline? I can tell you that from experience that I don't care what continuous delivery tool you use, this is a very difficult task to accomplish. And the reason primarily is everyone has their own kind of perception of what microservices are and how they should be implemented. And then the same goes for monorepos, right? Like, a monorepo may look different from the way Kyle and I interpret them or implement them versus somebody in AWS, right, or some team in AWS, how they implement it. So it's like you're in this constant state of uncertainty, I guess is the best word for it, because it's like custom for everyone. It just means something a little bit different for everyone. But we're going to try to tackle the normal, well, I don't say the normal, but the general kind of perception that everyone thinks about when they hear microservices or monorepos. The first thing I want to talk about is microservices, right? Like, what is that? Kind of level set some folks as well. Microservices is basically compared to the let's take a step back. Compared to the old way of, or the older way, I should say, of deploying software. The way software was kind of written was everything was just in one application. So a lot of the services were just in what we call a monolith type of application or structure for your application. And that just meant that, you could have let's say a user permissioning system inside of, the complete application. You could also have a front end, right, in that same app. And these are all separated by classes, usually if you're using object-oriented type programming models or paradigms. And we quickly learned that, okay, those things grow, right, when you have everything kind of encapsulated into one application. And we also kind of discovered that these applications can kind of be distributed, right? So meaning you can break them down into their true, form, which is just if you have let's say an authorization service that's bolted or built into your monorepo, or your monolith, I should say, then you can tear that out, right? Tease that out and kind of create its own service. So that's not super dependent on something, right? Like the monolith. And then you can also leverage that service in other applications, right? Not only your monolith, now you can start, creating, maybe using that same framework for a separate kind of service, right? It could be a front end, could be an API service. But at the end of the day, you're using a centrally managed, user authorization type service. So that's what we mean by microservices. It's essentially, smaller, specific in scope type applications that serve a specific purpose with zero. The goal is zero dependencies. And that's what I mean by everyone does it a little different. I've seen implementations where they say it's a microservice, but there's still a dependency because maybe they teased it out of or decoupled it from a monolith, but there's still certain dependencies that monolith provides to that service. So in my opinion, or in my mind, that is not a true microservice. That is just, I don't say, maybe a half a microservice. I don't know. What do you think, Braeden or Kyle? I don't know what that looks like.
I can get behind that, half a microservice.
Right,
like you said, everyone's definition's a little bit different, which is why we're going to kind of go over something that hopefully you can tweak. But I wanted to inject in there kind of a difference between the two, something that we're going to kind of go over here, and something that makes this a little bit easier, a little bit harder. When you have a monolith, I think one of the reasons a lot of people might choose to do a monolith, well, one, it might be easier. I don't know that I necessarily agree with that today, but that's definitely why people might have chosen it. But also, there's a complexity to microservices that we're going to be helping to solve today that you don't necessarily have with the monolith, depending on how you do it. And that is, normally you version your monolith once. So the whole application gets this one version. And something that might scare some people in a microservice kind of architecture is typically each one of those microservices actually has its own version, because each one of them is its own application and you work on it independently, which is also nice for a lot of reasons, right? Because you can actually focus, if you have a bug in something, you're actually focusing in one specific area, and that might be in multiple repositories. Today, we're going to be talking about a monorepo, not to confuse with a monolith. A monorepo means that we have multiple microservices in a single repository. A monolith meaning that we have one service also in one repository.
Yeah, that's a good point. So what we're going to show you today is definitely not a monolith, but two separate services, but they live in a single repository, and that's called a monorepo, right? So again, monolith, monorepo, they both have mono, and they both have a single kind of location, right, for the services, but they are different. Again, and the big difference is a microservice should be kind of, again, an application on its own, right, with no dependencies to anything. So if you spin that thing up, it should work. And then if you have a front end, let's say it's an API, that's serving up data to a front end, then that front end is also a separate application. You spin that up, right? They should operate, even though they may not connect because one may not be, available, right? That app should still spin up and execute. It may not execute as you intended if both of those services are, if you're not up and running, but you'll know right away that you have an issue. Hopefully programmed all that error handling right appropriately in that. So now that I kind of chatted about the differences of microservices, monorepo, and monoliths and all that good stuff, I did want to say that these concepts are not new. Distributed systems have been around forever in the form of mainframes, right, and other type infrastructure topology. But I think the technologies that we're using today are definitely newer and more appropriate, right? So things have kind of been sussed out over the years, and we figured out this is a cool way to run distributed systems. And a lot of it has to do with the cloud and how companies like AWS have provided, these services, and the way that they implemented that stuff is definitely in a distributed kind of model, right? Which is pretty cool. So I don't know, Kyle, what should we start with? Just jump into, let me start sharing my screen and we can jump into, let's just share the repo real quick.
Yeah, I was going to say, maybe we'll, what I would say, let's take a look at the application we're going to be putting up. So this application we're talking about is composed of microservices. So we actually have 2 microservices. Both are Dockerized. There's a Python API service and a JavaScript application, client-side application that runs in just totally client-sided. Both will be Dockerized, and we're going to put them up in AWS via what service, Angel?
So we're using, for today, I'm going to be using Elastic Container Service. So just so you know, we've already kind of pre-baked or deployed the backend to this application. The reason is, it's like a cooking show. I'd rather have like the pie already pre-baked and then show you. Really, nobody cares about the API service, right? For this demo, at least I think the front end is a little bit more intriguing. So we'll be focusing in on that. But the code is there for both, right? So,
cool.
and if you need to reach out again, just hit us up, and we'll share the URLs for these. All of those code examples are available for everyone to kind of play with after or during, however you want.
All right. So you ready for me to share your screen, Angel?
Yeah, go for it.
All right, here we go.
Yeah, so let me plus this up a little bit so that it's a little clearer. But this is my fork of the project. So we're going to be using this for the demo today. And here are the applications that Kyle was kind of talking about. So I just cover this real quickly, right? We have what we consider a monorepo, and they're separated by a directory, right? So the front end is in the front end directory, try to make it simple for everyone. And the back end is in the back end directory. Really simple. If you go there, as Kyle was saying, though, these are actually separate applications that we also host. So if you don't want to use any of this the way it is in a monorepo kind of manner, you can just click on, the specific project, and it'll take you right to the actual project, right? So this is, so that in case you don't want to, do monorepo stuff. So let's take a look at the front end. The application itself really doesn't matter for this demo, right? What we want to show everyone is how you can incorporate, monorepo type execution within your CI/CD pipeline. And like I said earlier, no matter what platform you use, it's really, really hard to get monorepo interaction within a CI/CD pipeline. And the reason is, right, I think there's a couple of things that attribute to that, which is Git itself, right? You can't have projects within projects or Git projects within Git projects because of the inheritance, right, and the way that Git is kind of composed. So that's a challenge, right? And we've actually had customers, build. They wanted to use a monorepo kind of approach to their code and in their CI/CD pipelines, but it was really difficult because the way the platform was instrumented back in the day, and everybody kind of followed the same model where like it's just one code, right? Like one project within that. And then we recognized that, we need to do something about that and enable developers, right, to be able to manage their pipelines in whatever situation they want. And not only that, we also wanted to provide a much more flexibility for people to execute their CI/CD pipelines. And I think, Kyle, this would be a great time for you to kind of jump into maybe like what we call dynamic configuration, right? So maybe start off with the static one real quick, and then jump into why it's dynamic.
Yeah. So just to expand on what you were saying, it did a perfect segue. One of the problems you would have with a monorepo, typically in a CI platform, is it depends on the level of complexity of your config. And CircleCI these days, we call our config language version 2.1. If you've heard of CircleCI, we've been around for a while. We used to have CircleCI 1.0, and that was even more simple, right? And the way this would work is every time something happens in your version control system, this time we're using GitHub, it triggers something to happen on CircleCI, and that something is what's defined in your config file. So if your config file has a workflow that says test all the stuff, that's exactly what's going to happen. And if you have a mono repository, what you're going to find is that you're going to end up running things you don't necessarily need to run or have to run. And you might only be focused on a particular subset of that code. So for instance, if we're working on the back end, we don't need to be testing or deploying our front end necessarily, right? And typically, if you were working with separate repositories, that's exactly what you would do. You would have a front end, you would work on that separately, you would trigger it, it would deploy, so on and so forth. But when you're working with a mono repository, we have to find some logical way of separating that. So that's what I'm going to show you. Braeden, could I get my screen up on here? Thank you so much. All right, so okay, thought I wasn't in the right place for a moment. So let's take a look at the .circleci folder. And today what we're showing you is dynamic config, which is brand new. So if you're at all familiar with CircleCI, this is going to look weird right off the bat because we have 2 config files in here. And that's not typically how we've used CircleCI in the past. But today, that's what we're going to be resolving. So I'm going to go into our config.yaml file. If you are new to CircleCI, the way that you can use CircleCI is you create this .circleci directory, and inside there you drop in your config.yaml. This is the file that gets read every time you trigger some code change. So you make a commit, you push it to GitHub, CircleCI downloads the config.yaml and runs it. So let's just take a quick look at what's in our config YAML. And we have a few things to go over here. And I'm going to try and keep this at a high level so that we don't have to dive too deep into the inner workings of CircleCI config. But of course, we absolutely can. And if you have any questions, feel free to put them in the chat and we'll get into it. So let me quickly go over a few things on the top level keys. First of all, I mentioned before we're using 2.1 configuration. That's what gives us access to certain features on CircleCI. That's all that is. Orbs. Orbs are a package management system for CircleCI. So you can write configuration, and we're going to show that in just a moment. And rather than copy and paste that into multiple projects over time, what you can do is abstract it kind of like a class or anything like that. Or if you're familiar with NPM, like an NPM module, you can extract that out and you can put it up on our package repository, the orb registry for orbs, and then import them into multiple projects. So what this is going to let us do is use multiple config elements, which I'll go over in just a moment. So what we're actually importing here is an orb called path filtering. And if you were to head over to our, excuse me, our CircleCI registry, you could search up path filtering and get some more information, some examples and such, but we're going to go over it kind of live. So let's continue on. The next thing is a new key to CircleCI, this setup key. And when we use this new key, setup true, we're instructing CircleCI that what we're doing right now is we're getting ready to run a different config. This is the new way to run more than one config. So typically in CircleCI, we would have just this config.yaml file. What we're going to do is actually run this config, and then later on, we're going to run a separate config file. It's going to be part of the same pipeline. And what that's going to allow us to do in the end, what we're going to be using this path filtering for, or path filtering orb for, is to only run a subset of our pipeline based on what's changed. So if we have updated the back end, we'll run tests for the back end. If we've updated the front end, we'll run updates for the front end. Same thing for deployments. We're only going to affect one part of this repository at a time. So let's skip down to workflows. Workflows in CircleCI is a list of jobs that we're going to run in some particular order. Now, typically we would define some jobs here that we need to run, but we don't have to right now because we're actually importing that from the path filtering orb. That's actually the bit of config that we're bringing in from our package manager. So we have one workflow called run filter, and it contains a list of jobs. The job that it contains is only a single job at the moment, and that's from the path filtering orb, and we're using the filter job. And again, if you were to go over to the orb registry, you could see here that the path filtering orb has a single job called filter. And there's a description and some parameters here with more documentation. But we can take a look at what we have here, and it's pretty self-explanatory except for down here, which I'll explain. So we're comparing the changes on whatever branch we are currently on to some branch to see if something has changed in the pull request or on the branch that we're working on. So we have a branch called main, and let's say we open up, we're adding a new feature to the front end. We'll some branch, new feature front end. What we want to do is compare our current branch against the main branch. And this is what's going to detect if either the backend or the front end directory has changed. That's what this mapping parameter is allowing us to do. And what happens is if any files in these directories have changed, what we're going to do is set a parameter value called run front end or run backend to true. And then we're going to pass that parameter along to the API with our new dynamic config file.yaml, which is the second piece to all of this. That's our actual config file that's going to do the work. That's everything that contains our testing, our deployments, and everything like that. This setup config that we're talking about right now could do much more. I'll go into that in a second. But at the moment, at a base level example, what it's doing is just detecting where has something changed and what should I do about it. You could also be using, go ahead, Angel, I see you.
No, finish your sentence. I was going to say, like, if you want to switch to my screen, I have a side-by-side, so maybe it's a little bit clearer. So Braeden, if you could just like switch to, so
there
like,
we go.
Yeah. So I just wanted to call out, like, because this can get confusing. Like, so CircleCI will always execute this config.yml file, right? And if you constitute a setup and, equals true on that key, that's just kind of prepping the system for some follow-up, like Kyle said, workflows. The reason why I wanted to show the side-by-side, because even myself, when I first saw this, I was like, whoa, how does this work? But like Kyle said, right, we're checking for changes in the different projects within our mono repo. And there's like this comment says, there's 3, right, column space separate table, I guess. So every value separated by a space means something. In this case, right, we're saying, hey, check for any file changes in the front end directory. And then if there is something that is true, right, you're going to run front end. The front end, you're checking the front end parameter. And if you jump over to the actual, right, dynamic config that is listed here, this is where those parameters are kind of defined, right? So if you're following along, and I'm sorry, Kyle, I probably jumped the gun.
No, you're good.
But we have this config key, right, that says, all right, we're setting up a new workflow. Which file should I be using? Now, if you look, right, we're defining that as well here. So all this really does is says, all right, if anything changes, jump over here, and you're setting this to true, right, or looking for a true value. And as you can see, you're setting it to true. But if you see here, they're set to false by default, right? So I just wanted to kind of call that out and show the side by side so that folks are not
helpful. Yeah, thank you for that.
Yeah,
this is a kind of slightly different way, but thank you. I think this right here actually helps visualize exactly what's happening.
Yeah, let's keep that up for a moment. I also want to point out that what we're doing here is we're using an orb. I just want to stress that that's not required, and you could do there's lots of ways to accomplish this. We're just showing one particular way, and there's a possibility that it's a little overcomplicated for this. But let me just explain. First of all, there is just an API call that you send some data to, which is in this case the config file. But what we're doing is we're writing an orb here, and again, you don't have to use it. You could just call the API, or you could write your own orb to use this one config file with these parameters so that we can actually instruct which jobs we want to run. I want to stress that you could have also, for instance, instead of using parameters or anything, you could have had an additional config file, like one for the front end and one for the back end. And rather than setting parameters at all, we could have just, for instance, ran one config if it was a change in the front end and one config if it was in the back end. So it's very flexible like that. So this is one example of how to do it with this orb. You can make use of the API yourself. We also have other orbs that are kind of similar. Like we have the continuation orb. I'm not going to go into that now, but just wanted to highlight that this is not something that's like built into CircleCI this way. And if you don't like the mapping or anything, because I know it can be a little confusing, certainly not necessary. I mean, there's a lot of ways to go about this.
Right. Yeah. I mean, one of the things that I wanted to also call out is that, we built our features so that, when we introduce new features, we try to keep it close to, what everyone's kind of used to, which is YAML, right? So like it's the new data structure, right? It's not a programming language. It's a very nice declarative data structure that we use to configure things. In this case, we're able to declare commands that we want to run. So that's why, I have mixed feelings about, personally, I have mixed feelings about using YAML in like this case, but with dynamic config, you can actually kick off, scripts. Like if you have a Python script that does all your logic and then produces a config file, right? Like this dynamic config could actually be dynamically produced or generated, which is another use case. Anyway, what I want to do is focus in on our monorepo microservices kind of example, because I think a lot of folks struggle with that, and even myself, right? Like I said, when you go to different teams or talk to different organizations, microservices and monorepo mean completely different things, right? And then they layer other concepts on top of that with like GitOps and DevOps and DevSecOps, right? Like there's a lot of things going on. And again, those things even kind of mean different things to different organizations and teams, which I think is cool because, right, I'm not a big fan of like, one size fits all kind of thing, right? Especially when it comes to my technology. I really like to have the flexibility to do things the way that will fit, my needs better, right? Make me more efficient, make me more, run things more optimally. So, is there any, Kyle? Yeah, let's continue on. I'm sorry.
Yeah, actually, do you mind if I completely derail this for a moment to answer a question in the chat? Because I feel like I wanted to skip over it, but I feel like we're gonna have to just talk about orbs real quick because it's really hard to talk about this without like fully diving into it. So I'm gonna share up my screen again. And let's do a quick information on orbs.
I'll release it for you. Go ahead.
There we are.
All right.
Okay. Cool. So the orb registry, and the question was, let's see, great. Orbs are like modules extensions for regular CircleCI pipelines. So yeah, basically you can write CircleCI config and you can turn that config into an orb so you can reuse it. So I just want to kind of show off the node orb real quick because I think it'll make a lot of sense to what we're actually talking about. So the node orb comes with a few different components. We have jobs. Let me make this a little bit bigger. We have jobs and commands, and that's really the main piece. We also have executors, but let's just take a look at the test job. So it's a simple drop-in job to test your Node.js applications automatically. And we have some examples here. So let's take a look at this run matrix testing. What this will do is drop in the job, and we're going to take a look at the source in a moment. What this will do is drop in the job so that if you can see here, we're testing our Node application against 3 different versions of Node, and we're able to accomplish this in just 13 lines of code. But what we're doing is we're importing that code, so it actually looks much bigger. And what I want to do is quickly show you what the source of this looks like. It's going to be a little messy, but let me just pop in here. So you can see we have some steps. And this is typically how you just write regular CircleCI config. So the first thing we do is we check out your code. That's a native command to CircleCI that goes and clones down the code. And then we run a command called install packages, and that's coming from this orb as well. And all that's really doing under the hood is just running npm install, but it's doing it with some parameters and such so that it can work for yarn and yarnberry and everything like that. We're caching. So these are typical caching steps. And towards the end, we're finally just running npm run, and you can run npm run test or npm run whatever script you want. But we're able to take all of this, compress it into a job, and then you can just go ahead and use the example up here. So actually, if you only wanted to test 1 version of Node instead of 3, you could get this done in 7 lines. So that's all that's going on with that path filtering orb is it's taking one of these jobs, running some bash, running some commands, hitting an API. So I hope that answers the question.
Yeah, let me add to that too. So when we're talking about orbs, all we're really doing is encapsulating functionality, right? So kind of abstracting that away into a usable, a usable kind of call or class, right? So if you think about object-oriented programming paradigms, this is like encapsulation, right? So and then we're providing kind of the objects, right, that you can instantiate based off of these classes, if that makes sense, right? So and the reason, and another benefit to that is, all that functionality is managed, centrally managed, right? So if you need to make a change, we do version those, number one, but we also, right, you can make one change and it will impact whoever, right, wants to implement that. And if you don't, you just use the older version and continue going, with your work. So just think of the orbs as more of like an encapsulation of some functionality. It could be like you saw with Kyle's example is, we've put some functionality around making it easier to implement, like, or leverage our node executors and our node images. So like you don't have to manually set the caching mechanisms, right, in your pipeline, and that eliminates
side by side. If we can pull that back up,
and that eliminates that will eliminate your need for like extraneous volume, right, or extraneous calls within your YAML, right? So you want to keep, as programmers and developers, we all want to keep our code really terse and concise. One way to do that is to not have a lot of code or syntax, right, in your code. So this is one way to also help with that, right? Like make things more readable, more manageable. So I just wanted to kind of interject around orbs to give our developer friends a little bit better.
Yeah, sorry, here's the direct side by side. This is what you would write if you wanted to just test an application on CircleCI. And I think it's hopefully pretty explainable here. You have a job called test, which is running in a Docker environment using some node image. There's all those steps I was talking about before. Check out, restore cache, install packages, save cache, run tests, and then finally you want to invoke that job in your workflow. Or this is what it looks like when you use the orb directly.
Nice.
All right. I think I've exhausted the orb explanation.
Yeah, I'm kind of falling asleep on it.
All right, let's switch it back over to your example, and we can continue the second half of the dynamic config there. So on the right side. So now we've actually, in the first config, we've tested what's being changed. And now we know if something changed in the front end, we're going to set this parameter to true. If something changed in the back end, we're going to set this parameter to true. And let's actually, before we talk about the jobs, Angel, can we collapse that? We'll just go right to the workflows real quick, just so we can get the high level.
Oh yeah, you want to go to on the dynamic, yeah?
Yeah.
Yeah. Let me just. Yeah,
perfect. So just take a look at this, and then I'll switch it over to you, and we'll dive in. So this is what we're saying here. You can see that there's two workflows. We have front end and back end tests, and each one of them has a when conditional on there. Now that's a native thing in CircleCI. Again, we only want to run this workflow when some parameter is set to true, which of course we were just talking about was set by that path filtering orb in the setup workflow. So let's assume that both things are going to run just for sake of argument, so we can take a look here. In the front end workflow, we're running a set of jobs, one called front end test. Then we have building our Docker image, deploying it to AWS ECS, and then we have an approval job that's just waiting for us to destroy the infrastructure, which is, I believe, just for testing, right, Angel? I mean, I don't know that you.
I build. Yeah, this is like a demo, but generally, when I build software, I like to build the artifacts that are going to be used for deployments, right? And then also deploy those artifacts to test my deployments, my mechanisms for deployments, and ensure that the artifact that I'm targeting for deployment, I'm building the artifact for the target environment that I'm going to deploy to. I want to make sure that that thing actually, at a minimum, gets deployed properly and then functions. So we do what I call a couple of smoke tests, right, after a deployment, and then I just crush all that infrastructure because I don't really need it. But at the end of the day, the result is I have fully vetted that artifact, and my release manager can be a little bit more confident, right, with that release and say, yeah, this thing deployed to whatever. In this case, it's ECS, but if you're using Kubernetes or you're deploying it to maybe a Tomcat server or an Nginx server, whatever, I don't care. The point is, you can package everything up and then run it or at least you have that high confidence that it's going to run no matter what, right? For that target environment.
Yeah, perfect. So we're going to be focusing on the front end and assuming that we're making a change on the front end. So do you want to dive into what those jobs are actually doing?
Yeah, let's go ahead and do that. So I'm going to collapse that, and take this out.
And let me actually ask a quick question just to clarify, just to summarize for those who are joining with us.
That's
So
right.
the purpose of this looks like it is to, we got the mono repo, which is all the microservices in one repository. That doesn't mean it's a monolith. It's just all the codes in one place. And what we're trying to avoid is running a test over the whole thing, over the whole repo, when we don't need it, when really we really just need to be testing a certain section of the code. And so this is what it's addressing. Is that right?
Yeah, deployments as well. It's letting you treat, even though you have one repository, we're treating each of these directories, front end and back end, as entirely separate applications, and they each have entirely separate workflows. Like I said before, you could actually have these two workflows that we have here, the front end and back end. They could be at separate files if we wanted to. So you would end up with 3 config files instead of the 2 that we have now. And yeah, so typically you might deploy when you merge your branch back into main or something like that. And what this will allow you to do is you'll only be deploying the one service that's been updated for the branch that you're working with. So this lets you completely logically separate them, even though they're in the same repository on GitHub. So totally separate microservices, one mono repo.
Got it. Thank you.
Yeah. And again, right, this is a way. So it's just a way for you to orchestrate your pipelines, your CI/CD pipelines, to the manner that is to your liking or to your needs, and then also being able to be super efficient and running these things optimized. We're going to kick this thing off, and we're going to trigger this particular pipeline, and we're going to show all of this. But I think we could take a moment to discuss, the dynamic config pipeline, the thing that's actually going to run. So we talked about workflows, which essentially are what I like to consider orchestrators for jobs, right? So jobs are just a definition or a grouping of definitions specific to like a group of commands. So what I mean by that is, let's take a look, right? So jobs is a list, right? And in this list, we have a list of jobs. And this front end -test is a label for my job, right? It's just an identifier. You can call it whatever you like. In this case, we call it front end -test. And then the things that you need, right, to actually execute these code changes is what we call an executor or a compute node, right? It's an underlying runtime that enables, obviously, this code to be executed on, right? In this case, we're going to do something really cool here because this is another new feature that we recently released. And we're leveraging what we call an ARM compute node. So if you're familiar with ARM processors or ARM architectures, CircleCI now has native resource classes. So this is just a type of executor, right, that you can implement and execute your code on. Prior to us introducing this, you would have to do cross-compiling, right? And that, I don't know if you've ever done that for different architectures. It's a real pain, and it takes a lot of time, right, to accomplish. And the reason is these processor architectures like x86 and ARM have different instruction sets, right? So obviously, you have to compile for those architecture instruction sets, and again, they're not compatible. So this is a really big deal, at least for CircleCI, because now developers again used to have, if you wanted to distribute your application and your code, which is completely agnostic, right? Code doesn't care where it's going to run for the most part. You have to compile that, right, for a specific architecture or hardware. In this case, you can now say, hey, I want to, run a job that does ARM compilation of native ARM resource classes, or you can do both, right? x86 and ARM, and now you have two artifacts that can be, executed on either architecture, right? Whatever you want. You have options, and most projects do this already, right? This isn't anything new, but we're just trying to make it easier for the developers to implement this stuff without having to do too much, right? So at the end of the day, what we're doing here is just saying, hey, let's do, you select your resource class, arm.medium. If I wanted to do x86, I just chop off that arm and just have a medium value there, right? That's kind of the default. Like Kyle said, we're going to check out, right, this the code changes from the repo. This is a special command within CircleCI, kind of it's an alias to help make things a little cleaner and easier, right? So just think of that command as like a git clone. And then we're leveraging our node orb right here to essentially install our dependencies. And then because we are in kind of this mono repo situation, we need to tell node where the project is, right? The node orb, so it knows where the package.json stuff is, right? All those dependencies are, and then it also knows like, all right, this is for this specific directory, right? This application, and as you can see, we have what I call run block or run command, and that essentially just enables you to list the things you want to happen. In this case, we have a single command, which is just test this application, right, using npm test. So that's kind of like the front end job, right? So this is literally just like a unit test that's run, and you'll see how this all ties in the CircleCI dashboard.
It's probably worth mentioning, just in case. I mean, we're assuming people, I don't know what level everyone's at, but it might be worth mentioning the reason why we're doing it like this with this stage is if you open a pull request, and this is just going into what is CI. If you open a pull request against the main branch and you've violated some test, like an npm run test, you don't want that to end up in your main branch. You don't want that deployed, right? So what CircleCI is letting you do is automate that testing. And then if that test fails, one, it'll turn red on CircleCI, but two, it will prevent you from merging on github.com or whatever your supported VCS is. So that's just an explanation of, why are we even doing these kinds of things?
Well, no, that's a good point, because normally you would do this, most developers, as especially if you're doing test-driven development, you're writing a test locally, and you're building your app based off of failed tests, right? Or the functionality. So you want to make things fail initially and then make them true, right? So that's how kind of test-driven development works. In this case, as a developer, right, you won't have to manually run these tests anymore. It kind of goes with the flow of how a developer works. You write some code. When you think it's tight, you may run a simple test on your local machine. That's okay. But the true test is testing it in another environment, which is what you're doing when you're implementing this thing, right? This CI/CD pipeline. You're actually kind of implementing these things in a separate environment that's not your local developer machine, right? So how many times have we all heard like, oh, it worked on my machine, I don't know why it's broken now,
I've never heard that.
Yeah, I've never said that, right?
And we're saying, Angel, not just another environment, but ideally the exact environment you plan to deploy to. So, you might have whatever set up in your machine, but what's really cool about what you have here is if we plan to deploy on Graviton on AWS, the ARM offering, what we're doing here is we're actually building and testing our application on the exact hardware and in the exact environment that is on AWS. So that gives you that level. You might not even be able to do that locally, for instance, right? Like if you're on a might be a bad example, but like if you're on a Mac and you need to build for Windows or something like that, you can use CircleCI to build for Windows in the cloud as well.
Well, yeah, the main thing though is just being able to know that it works outside of where it doesn't matter for me. It doesn't matter the target environment, outside of my development environment. If it's working there, more than likely, right, the chances are it's gonna work, and that's part of the whole mystique behind CI/CD, and people don't really get that, right? It's like this helps solve that. It worked, but it worked on my machine problem, So anyway, let's jump over to, I'm going to skip the backend test because it's kind of the same thing, right? We're just doing it for Python. I don't think to me, it's not very interesting. Let's take a break though. Do we have any questions or comments that we're seeing? I don't see anything. But
I think we're good, but we'll bring them
so
up as they come.
If anyone has questions about any of this, please ask them. That's more valuable to me, is to get folks' questions and comments answered. So the next thing, so this what I'm showing you here are the individual jobs, right? And again, workflows orchestrate those jobs. But we're going to deploy to the Elastic Container Service on AWS. So we need a container, right, for this application. And this job right here, which I'm calling build Docker image, I think it's self-explanatory, but what we're going to do is build a Docker image. And in this case, we're going to deploy to, again, ECS, but I want to use, right, Amazon's awesome Graviton 2 instances, right? So Amazon has, I don't know, it's pretty recent, right, released this Graviton 2 capabilities, which essentially are, instead of x86 ECS instances, you now have ARM version 8, I believe, instances available to you, right? So what we're going to do is build an ECS cluster with ARM AWS Graviton 2 compute nodes that will power that cluster. So hopefully, if the demo gods are with us today, we will have a fully functional deployment, right? So this is really simple. It's just, again, right, just defining the executor where I'm going to run my code. In this case, I want to build an ARM image. So I need to run this on an ARM resource class or compute node. Checking out my code again, since it's a node project, I want to do the same things I did in my test, right? Install my dependencies. And then also, this is the actual job that's going to do things, right? And here's a list of commands. Unlike the previous command list I showed you, right? It was a single command. If you want to do multi-line commands, multiple commands in one shot, you have to add a pipe character and then, just do a rundown of what you want to do. In this case, we're going to change directories into the front end. I'm going to install the Ionic CLI, which is a requirement for this application to kind of build it. We need an environment file. Again, like I told you, we pre-baked our backends into a Heroku instance, so that's where this is pointing to.
You're showing the cooking magic.
Yeah, and then we're going to build using the Ionic CLI, right? So we're going to build a distribution. So that what this does is basically builds a folder for us. As a matter of fact, let me bring up the while I'm here. Let me bring up the. This is really important too, by the way. Since we are building a Docker image, right? We need a Docker file. So this Docker file right here is pretty simple, right? We're just taking this this distribution piece, and we're just pushing it over to the application directory where Nginx is going to pick up and start serving up our application. So one thing I wanted to note though here, if you're going to do any type of ARM Docker image building, you will have to prefix your any image, right, on the Docker Hub, or in Docker Hub, I should say, with an ARM 64 V8 prefix. And the reason is I was just having a really interesting conversation with someone the other day when I was on another stream and talking about this. They were like, no, why don't you use the official, Docker Hub version of this? I'm like, this is the official, right? So I'm actually using the Ubuntu official image, but this is, if you don't have this prefix, it's going to be an x86 architecture by default, right? So what I'm saying here is, give me the official image, but I want the ARM64 version 8 version. So that's how you would, call up an official image on anything that's living in Docker Hub. That's how you would do that. Otherwise, it's going to build it using. Well, actually, it's going to. I don't know if it will. It will take a dump on you and tell you, hey, this is not good. Like incompatible, like we talked about. So just be sure to, if you're going to deploy a Docker image to an ARM capable Docker image to an ARM infrastructure, like what we're going to do, you need to have this. Otherwise, your image is not going to start, just going to churn over and over and over. Until you
tip. I'm sure this is going to save somebody like 6 hours of time.
Yeah. I myself struggled with this a few weeks ago because I don't deal in ARM. Either I download the binary that's compiled for ARM, right? But in this case, we're going to build Docker images. So if you're looking to do anything with ARM and Docker images, definitely put that in front of anything, and it will pull down if it's available. By the way, like right. So if the official packages have it available, you'll know right away. It'll tell you, I don't know what this is. That means they probably don't have an ARM, an ARM binary or an ARM capable image. So, okay, I just covered that. Right. And most official ones do have it, but there are some that won't. Right. I don't know off the top of my head of any, but I'm sure if I start digging deep, I could find some. So I'm going to close that out and jump back over here. So we kind of did the distribution package build, and in our Docker file, right, we're just copying that into our image. So we have the application. Once we have that, we're going to start, doing the Docker build, which is the actual process of telling the Docker client to build me an image, right? And by default, it knows where the Docker file is, which is represented kind of like here. So it's in the same root, right, as the directory as the front end. There is a flag for like -F to tell it where exactly that file lives. But this period here is kind of saying, hey, it's in this directory that we're working out of. But one of the things I also wanted to call out here. So if you're ever like building a Docker image, sometimes, well, a lot of times you want to identify the release, right? So you want to tie that Docker image not only to what we call the latest tag, but also to a specific release. And that's what these -T things are doing. What I'm doing here is leveraging environment variables as well, which we'll get into. But essentially with CircleCI, you can actually save secrets, right? Like maybe API tokens or username or any kind of sensitive data. And it's protected in our environment variables kind of section. Now, there's a couple ways. I'm going to use a project level environment variable, but there are other mechanisms to do that. And then I'm just going to call it front end, right? So this right here represents the latest. So I'm building a Docker image which will have the latest kind of tag with it. This other -T is another tag for this same build. But at this point, you can see it's a little different, right? I'm actually giving it a version number. This pipeline number actually represents this is a CircleCI specific environment variable or parameter variable is what we call it. And what this does is it enables you to like call or leverage numbers or identifiers within the CircleCI platform. Let me take a quick jump over to my other screen. Yeah, let me show you what that looks like in CircleCI's dashboard. So this is a dashboard, right? That pipeline number that I was talking about is represented here. This is the identifier, right? So it kind of pins and ties everything together for every release. So if I go back to my code, that pipeline number, right? And then this is just kind of a attempt at Semver. You can do this many different ways. I'm just leveraging this for the demo. But essentially what's going to happen is it will build me one image, Docker image, but have multiple tags, right? And I'll show you why that's important. So typical Docker client thing, right? I have to log in to be able to push to my account on Docker Hub. And again, right, leveraging the Docker password environment variable, which has my actual password or my API token or Docker Hub token embedded in it. It's protected at rest, in flight, and when the pipeline needs it, it decrypts, uses it. And then finally, we're going to do a Docker push, which is essentially pushing this up to a repository. Now, I want you to note this -A. It's really important. What that tells this push command to do is, not only push the latest, but push all the other tags that were built too, right? So, and let's take a look at Docker Hub and show you what that looks like. So this is the repo, my repo on Docker Hub. And as you can see, right, I have a latest tag and I have a 0.1.38 tag. Now, if you look, the SHAs are the same. Where are the SHAs? Here you go, the digest, right? You see that? These two things are the same. That means it's the same image, but these are the different tags. So you can call that image, different ways. The reason why you want to have the latest is if maybe you just want people to just pull down the latest, right? And you don't want to throw a tag number there, or you want to be more specific. In this case, in my pipeline, I want to be specific, so I want this image to be tied, right? So that when I deploy it, I know like this Docker image is tied to pipeline 38, and if there's any kind of issues, I can go back easily backtrack. So again, it's a mechanism for versioning, and it's a real simple way to do it. So yeah, let me jump over to the code again. So that's kind of Docker images, and building them in the CI/CD pipeline. Now, again, important things are the Docker file, making sure if you're doing, we're doing some stuff with ARM, we're compiling for ARM, so you want that as a resource class. And then that's it, right? Push it up to the repo. I like to use Docker Hub during these demos. I know Amazon has their own Elastic container repository, right? Is that right?
Yeah, that's right.
All right. Yeah. So if you wanted to do that, you could also do that too. I just in demos, I like to just use Docker Hub because there's a lot of cool stuff there. But if you were like to privatize this and want to use your own ECR, you could do that as well. It'll look a little different, but we actually have an org for that I think Kyle wrote, right? So, you can leverage different things to accomplish that really, really simply. So let's talk about deployments, right? This is going to get a little bit more interesting. But then I want to also show off, like kicking off this thing, because this is what we're here for, right? To show some code off and actually show it working. But what we're going to do, right? So now I've tested my code. I've built my Docker image. I want to create this target environment, right? So that I can push a deployment to, and then, make sure that my application is functioning the way that I intended, or that we intended. So there's no difference here, right? We're going to do some more ARM executor type stuff. So I'll just collapse that. We don't really need to pay attention to that. But we have our steps again, checking out the code. This time we're going to leverage HashiCorp's Terraform to deploy this stuff to the ECS cluster, right? So not only am I creating the cluster, I'm creating everything from VPC to the internet gateway that VPC needs, to the subnets, to security groups, the IAM roles, all the things, right? So this is from soup to nuts, a fresh infrastructure that's going to be created. And we also have a Terraform orb, right? So the reason why we kind of obviously we built that to encapsulate the functionality, but to make it easier to install things, right? Like, so you need the Terraform CLI to do these things. And we're also leveraging the Terraform cloud, right? So I'm using that to maintain state, which is really important. So again, right, I'm just doing an install of the binary inside of my environment, my runtime environment. Then I'm just running like the init commands, which is initializing the dependencies for this. And then this isn't really necessary, but for the demo, we included it. The Terraform plan is more for like a local workspace kind of workflow. But in CI/CD, I would recommend you don't do it. And then right, you're telling it where your code lives. So just like, I don't want to say this is monorepo, but it's just the way Terraform works. Everything's encapsulated in directories. In this case, I'll show you where that lives. In the front end, I have a Terraform folder, right? And then there's an ECS directory as well. And then this is the Terraform code, right? So I'm not going to go into it because you can all just download it or fork it or whatever. And I don't want to bore you with all the details. But at the end of the day, I did want to address one thing, which is the apply command. So this apply command is a trigger, right? So it will execute your Terraform code for you, right, and create these infrastructures. This also leads to like infrastructure as code. I'm sure some of you have heard of it, some of you have played with it, some of you hate it, but it's the future, right? And it's I don't think there's like no turning back, right? You have to kind of understand those concepts. You're probably going to be implementing a lot of this stuff. And it's going to be awesome I'm really excited. I've always been an integrator, right? A developer integrating systems. And this is exciting for me because I used to have to do this by hand. Like if I wanted to stand up a server, I would have to take, build out a data center, plug in electricity, get a network connectivity, right? All these things. And AWS's, service makes that, like, obviously you don't have to do that anymore. They're doing it for you, but they're extracting all of that away so that you can focus on what matters, which is the applications. So triggering that apply, I have some variables. So Terraform enables you to create variables within the code constructs for your infrastructure's code. In this case, right, we need our Docker image name that we're going to deploy to be dynamic, right? So be able to, the value has to be flexible and be able to change. So that's how you would do this, is creating a variable, which is short for var here in this key. And then here's the variable name inside of my Terraform code. And then I'm using, again, that Docker image that we built, right? So it's a specific to this build. So this Docker image will be deployed, and it'll be 0.1.30, hopefully, or 38, whatever the pipeline number is, or the next iteration of that. So that's basically like creating all of that stuff, right? This is just a simple way to create that infrastructure. And think about it, right? Like, so excluding the Terraform code, which isn't that much, right? It's like 4 files. See, I'm just kind of going through them real quick. And here's the variables file, right? But right, like if I were to do this back in the day, it would be such a headache. Like it would be so many scripts everywhere, and not, and then physically putting these machines together, the networking, the physical security, the cyber security, all of these things that just made my head hurt. They're so much easier now. But going back to the dynamic config, within, like, let's say, like a couple lines of code, I'm building out a data center or infrastructure within a data center with very little effort, right? Like I'm not even doing it. I'm just doing a git push, and this stuff will happen based off of the criteria. And then finally, right, we're just going to tear all of that down, because after we kind of see it working and we understand that, hey, deploy to that thing that that we like, the infrastructure that we like, that we're targeting, then we don't need it anymore, and we don't need to spend the money, the effort. And then also it's a security risk in some cases, right? Leaving infrastructure up unattended for no reason. So that's basically the teardown. I know it's a lot of stuff. So is there any questions or stuff out there?
No, actually, can I just interrupt you for a quick second?
Yeah, absolutely.
Awesome, thank you. So for anyone that's just joining us recently, I just wanted to say that this is a Howdy Partner episode where we highlight partner solutions. And today we have CircleCI, who is demoing their product and talking about microservices and monorepos on ARM architectures. And we did have one question in the chat that I'm just going to show really quickly. But they're basically asking how you're passing credentials, and is it through like a variables file?
Yeah, I'm going to show you that. So let me just show you that, right? So actually, yeah, let me just show you that since the question was asked. I'm sorry, I'm looking for my, here we go. So if I go back to the dashboard, right, this is the project, right? So really easy way to wire this up. You just go into CircleCI.com, click on the GitHub or Bitbucket, VCS, whatever you're using. And then you just do a simple OAuth ceremony where you're authorizing CircleCI to monitor for code changes in that repository, right? So once you have that all wired up, you can easily go to project settings. And then this is where you would set those environment variables up, right? So obviously I'm going to be deploying to AWS, and I need these environment variables to be present so that the system can do its thing on AWS, right? I think everyone who uses AWS is kind of familiar with these keys. If you're not, you should probably check them out. It's just a programmatic way to access AWS's APIs, right? And do things on programmatically do things on AWS. And then here's the Docker login, right? Docker password, just sitting there. And then Terraform token, because I'm using Terraform Cloud. And I'm using Terraform Cloud to manage the state of my infrastructure, right? So like, if I were to do this without using Terraform Cloud and I run the pipeline and that infrastructure is still up and somebody runs it behind me, they're going to have a problem, right? Like it's going to be like, whoa, it's going to create a new infrastructure, or it could be like stepping over, right, the infrastructure that is existing because it doesn't know what the state of that infrastructure is. With this Terraform Cloud option, which is here, right? And then, by the way, they have free offering, which is awesome. Before this, you would have to kind of pay for it, but yeah, they did a great job at providing these kind of services for folks. So kudos to HashiCorp for that. But I hope that answers the question, right? So and we do have I don't want to get too involved. Yeah, let's not talk about context. Maybe that's another Howdy partner we can do a little bit more involved or complex things. So
there's actually a follow-up on the environment variables. Someone's asking if those are encrypted on the CircleCI side.
Yeah. So they're encrypted at rest.
Cool.
Yeah, at rest and in flight, right? So what I mean by in flight is when the pipeline kicks off, it needs to get that stuff, right? And it will get it right out of the system, but it's encrypted, right? Until it hits the runtime, then they'll be available to your applications for that. So yes, they're encrypted at rest in flight. We take security very, very seriously because we have multi-tenancy, right? Like there's multiple companies, multiple teams, organizations, individuals running their code in our infrastructure, in our build platform. So we definitely take security super, super seriously, and and they're also masked up, right? So like I'll show you in a little bit later. I think Kyle, what do you think? I think I covered everything. I mean, I want to answer everyone's questions before we move on. So is there anything else out there folks are asking or need some help with?
I have a good chance that you're about to cover what the majority of questions are going to be,
okay, cool.
But we'll keep it flowing.
Yeah. Well, So Kyle, let me get some assistance here. And what should I change to like kick off a build? Well, let's go ahead and kick off a build now. So I'm going to close all this stuff up.
So what branch are we on currently?
I'm on. Let's just use main, right? Or no?
Well, if we want to, I mean, we can. But if we kick off a new branch, then we can use the dynamic config path filtering.
Gotcha. All right. Yeah, I can switch over. Let me just do a quick. Am I still sharing? Yeah. Yep. Okay. Cool. Let me just jump over to my terminal, and let me do a clear, and then I'll do just to make sure. Cool. And then I just want to do a git pull origin. All right. Cool. So yeah.
So let's just make a new. Yeah, you should be.
Yeah, that's cool. So to make sure.
So let's just make a new branch. Cool. I mean, you can call it anything you want.
It's already there.
Okay. Okay, good. Yeah. So I want to point out that if we push this branch up to GitHub right now, what would happen is, can you pull up the config.yaml file?
Sure.
So we're talking about using that, the regular config, not the dynamic one.
Got you.
So we're talking about using this particular path filtering. Come on, man. Killing me here. No.
Hey, we're getting there. Here we go.
We're still not there. All right, here we go. So
we're going to show side by side.
Oh, good. Yeah, no, that is better. Like I mentioned before, there's a million ways to do this, but we're using the path filtering orb today, and we discussed before, maybe for anyone who missed it as well. We have the setup workflow on the left that runs anytime we push anything to this repository, and then this dynamic config on the right, which is only triggered via a certain set of events. We can see there on lines 16 and 17. What we are doing is using this path filtering orb's special mapping parameter, which takes in some special 3-column kind of like CSV style syntax there. It's checking for a change in the front end or the back end, and it's detecting that change based on if it's different from what is on line 13 there, the main revision. So we're on a new branch now, and anything we do is going to be compared against the main branch. So we can do literally anything. So if we just go into the front end folder, and I would say let's just add something to the README file in there for sake of argument. Okay. So in the front end, there should be a separate README file. There we go, right there. And let's just add a sentence somewhere.
I will. I'm going to add something really nice. Let's see. Kyle is
I know
so
it.
cool.
And don't you forget it. Someone insert sunglasses.
All right. So I've saved this change locally. I'm going to go jump back into my terminal and hack away at this. This type of get status. I always like to check, make sure that, you know, I'm going to push some stuff. So let's do a git, not a GTI, but a git commit. And then I'm just going to say, what was it? Front end readme. And then we just want to give it a little message, right? And then we'll say like, update. Kyle is, all right, cool. Cool. Sorry, man. Kyle is cool, right? Whatever. Just a little fun message to tell us that, or indicate our commit. So finally, right? Like every developer does this. We're going to commit, and then finally, you know, this is how you kick off the pipeline. Believe it or not, it's just get pushed, and hopefully this will get picked up, right? So the demo guys. So you saw I pushed, right? I didn't have to do anything, right? Like just detected my code changes. And it's going to run that path filtering thing, right? And look, it didn't run the backend stuff, right? It started running our front end jobs, right? Because there was no changes to the backend. That was
so we had those two workflows, but because we only changed something to the front end, we did run that setup workflow. You can see there, run filters, the name of that first workflow that ran, which just detected what changes happened. And now we're in the front end, so we get to skip all the Python stuff that you were saying.
So you kind of can see what that looks like, right? And here's that continuation pipeline, right? So like literally just a couple of JQ commands, you know, creating a file, and you're running a curl command to the API that Kyle was talking about earlier, which is the continuation API. And yeah, once you post to that, you're good to go, right? Like it's going to run.
Let's point out two things right there real quick. First of all, on line 57, you can see that we passed to the API a parameter called run front end true. And if we look at that dynamic config we wrote, that's what is actually triggering that particular workflow to run.
Yeah, let me close this up.
There we go. So we have those two parameters there that are false by default, but we just turned run front end to true, and then that sets up on the workflow. I want to show one more thing in that output, just to kind of recap on the question before about the environment variables. You can see that there is on line 54, we're also passing in a continuation key. Now, long story short, you don't actually have to explicitly set that environment variable. It's automatically generated by CircleCI. But it's the same as any other environment variable. So you can see that it's all starred out there at the end. And that's what's going to happen if any environment variable you add, either at the project level or the context level, in the UI here, it will always be blocked out. I just want to stress, though, in case you are going to do this, it won't be blocked out if you put if you save it to an artifact, like an actual file. Same thing if you connect via SSH or something like that, you have full access. So this is strictly blocking it out in the UI here.
Yeah, just be careful with your secrets, right? Like in this UI, yeah, it's all masked, like Kyle said, but you definitely want to have some OPSEC procedures around how you handle, access to things, because CircleCI does have an awesome feature called rerun with SSH, right? So if you have failures, you as a developer can do self-serve actions like rerun that failed job, and instead of like most tools do, they'll just run the thing, fail it again, and if you have some log files or some sort of standard out, you can debug in the blind, as I call it, right? Like it's really hard to do, but with this feature, you can rerun that job with SSH, and then what happens is it'll fail, right? The results won't change, but it'll leave that environment alive for you to SSH into and debug in the environment where it failed, right? So that's cool. Like back in the day, yeah, when I was doing this stuff, it was like, what? This is like
back in the day, we were doing this yesterday.
No, but I'm saying like when I was doing this stuff, we didn't have these features. So when I saw it, I was like, what? This is like, and this has been around with CircleCI for a long time. So yeah, like before I started working for them, I was also a customer, right, and a user. So So yeah, if we jump in, see our pipeline's still building. Typically, right? I mean, obviously, we're building a lot of infrastructure. Like I said, VPC all the way through, soup to nuts, right? And this even has auto scale groups, like the Terraform. So I'm going to show you in a moment what that looks like. But let's jump into. I don't want the testing's boring. I want to jump into like the Docker one real quick. I want to show you the environment variables Kyle was talking about. So anything here, right? This is like CircleCI generated, right? So this pertains to the specific CircleCI environment variables, or that's weird, but okay, it worked. But essentially, right, we spin up, we give you things like our what we call a build number, which is just that specific job that runs with this specific job, I should say. And then we also have things like, hey, the name of the job that's run, right? So you can keep track of that. It gives you one of the most important bits is the commit SHA, right? So you have that as well available to you. So you can do if you need to really, really be sure that this release is tied to whatever, you still have that. So there's a lot of cool things like the username who kicked off, right? Who made the change for that commit and kicked off that pipeline. And then also my favorite is I use this a lot to build my Docker images, which is the project repo name, right? So you can leverage those environment variables in your pipelines to identify and you keep these things dynamic, right? And related to the pipeline. And then finally, here's the secrets or the protected information, the sensitive information. We redact them here, right? So if you put them in environment variables, there's no way to get them because prior to them rendering they redact it. So I just wanted to show that off, as well as the last bit here, which is pushing that image up to Docker Hub, right? And again, since I'm using those environment variables in my username, right, the Docker login, it's masked that. So yeah, again, it's pretty secure. We take it very, very seriously. Security very, very seriously. Oh, great!
So that
everything finished.
Image was just pushed up to the Docker Hub, right?
Yeah. So let's take a look there. I'll do a refresh, and we should have 39, I think. So, wait, let's try this again. Sometimes Docker Hub acts funny, but yeah, there it is.
There you go. Yep.
Yeah. So we have that build right from build 39. So if we jump back over here, all right, trust me, there it is, 39 right there. And then from there, we have a latest, right? So these SHAs or digest numbers are the same. So again, right, our latest is now the latest and also pinned with a version number. So let's go to our ECS cluster. So right, this was pre me refreshing this page, but right now we should have, got to sign in again. No. All right, let's try this again. I'm going to jump over to my AWS quick thingy. All right, cool. So if I go to, not that, let's just do ECS. See, I don't have to point and click and create that. I saw a question about please just explain how Terraform works. Terraform is part of a concept called infrastructure as code, and that you can define all of your infrastructures that you want to provision in whatever environment. Like they have tons of providers, but you write out your infrastructure, right, in that code fashion. And then you're able to just execute on that code. That's the simplest way to kind of define what Terraform is.
Just to highlight an alternative that's AWS centric in case someone just happens to be more familiar with it. CDK is kind of similar as well. AWS CDK lets you actually write your infrastructure in a programming language. Terraform uses its own syntax. I'm giving options.
Oh no, totally different, but yeah, similar in concept. Right. But I like to use Terraform. It's just something I use. Yeah, you could use CDK. That's true. You can do this many different. You can even use different open source projects like I don't want to name any of them, but we can talk about that later. But so I clicked into my cluster, right? The first thing I want to show you is we have instances, right? So a cluster is always made up of some compute nodes, and here we go. I'm going to drill into one of these. to show off that we built a new cluster based off of and this is something I learned a few weeks ago of this T4G dot medium. This instance type and is a Graviton 2 ARM compute node, and the G is a designator for Graviton. I didn't know that until a few weeks ago. So if you're ever like looking at your instance types and maybe you're getting some wacky, cannot execute binary because it's just different, check that. Might be your instance type is a Graviton 2 ARM instance, and you're trying to execute x86 code on it. That's happened to me quite a bit, building out demos and stuff. I just wanted to let everyone know, like, that's a nice little indicator that you're on an ARM machine, or your cluster's powered by ARM. The other thing I wanted to show you was, we built a load balancer, right, for the application. Oh, wow, this is pretty weird. Okay, let's find the target groups. There it is. So this is the target group that we created using infrastructure's code. Again, right, VPC is included in that. This VPC was created. Everything was associated in code in Terraform. And again, right, you got 2 nodes, and they're both healthy, which is awesome. We want that. But let's go back into our cluster. So I kind of addressed, right, the instances. I hope that was clear. If you have any questions, just punch them up in the chat, and we'll address them. But since this is a container service, right, we created a service in infrastructure's code, and the way that the container service works is when you deploy something, you're defining that deployment in what is called a task, right? So a task is exactly that, a deployed instance, right, of the application or the container that we built. So let's drill into what an instance of our task definition, right? So it's telling us, hey, this is running. It appears to be, healthy. Everything's cool. We have 2 instances running on 2 nodes. You could actually probably have 4 instances running across 2 nodes, right? However you want to do that. I just chose 2 to be even and not confuse folks. But one of the things I wanted to show you was not tags, but I wanted to show you the task definition, right? So remember when I built my Docker image and created a name, using Terraform, I'm able to define, and I'm looking for the image name here just to show everyone. So what we're doing here, let me just go quickly here. We're saying, hey, the host port needs to be open at port 80. If you have SSL certs, you could do 443, however you deploy your secure infrastructure or your security keys and chain them up. Here we go. So this is what I wanted to get to, was this is the task definition. And then, wait, no, that's not it. There's the image name somewhere around here. It's always hard to, that's one thing, Braeden, maybe you guys can work on that. Making this a little easier to traverse.
Go to the non-JSON, right?
That sucks. that's too easy. That's too easy, right? Like that. Where did it go? Anyway, there's supposed to be a call here for a container name. I don't see it, but in any case,
there was your task.
There it is.
Oh, okay.
There it is. I found it. So yeah, that's the image name, right? From Docker Hub. So it's pulling it. So again, the task definition is just how you're going to deploy. You're defining how you want this image or this container to be deployed, and the characteristics you need, such as like where you want your logs to go, how much memory you want to allocate, CPU, resources, things like that. Just wanted to kind of call that out for folks. Now, the next thing is, let's take a look at, let's go back to the cluster a bit. I think I covered, the auto scale group, right? I wanted to show that because that's really important. And any, right, like that's the value of all of these things, is when you're using things like AWS, right? You want to deploy stuff and you want it to scale with very little manual intervention, right? And that's where autoscale groups are really helpful, because if you have a cluster of compute nodes and you reach a certain capacity threshold, right? Let's say both of our nodes are at like 75%, pegged CPU. that's kind of a threshold that you want, it's a flag. You want to add more resources. And that's where this auto scale group kind of comes in. And that's what we're doing here, right? So I actually have, I'm monitoring. I have created some, what they call CloudWatch metrics. Is that where, no, they're not here. Okay. So let's go back one. Details. I believe, let me see. It's been a minute since I've been in here.
I think I did see it on the monitoring tab.
You
So it's
did?
under
Okay.
Yeah, monitoring.
Yeah.
And then it's view all CloudWatch metrics.
Ah, there
Is
you
that what
go.
you're looking
That's
for right there. Yep.
Yeah. So right. I created, by the way, I also created all of these metrics and thresholds from Terraform, right? So if I ever need to change that stuff, I just change it in my code and then push it, right? And it'll make these changes on AWS for me. And it's versioned, it's in my version control, and everyone can on my team can take a look and see what the hell happened, right? If it's not the right thing, which happens quite often. But yeah, right. So like, you just essentially want to have some sort of monitoring always, right? When you're deploying things. Again, this is for demo purposes. So like, it doesn't really matter, but it's good to show that, how to do that when you're going to go into a live production environment. So again, right. I just wanted to show like you need these load balancing capabilities because, right, you want to be able to have that elasticity to be able to scale up and down, scale up and down with the resources that you have. You want to route that traffic using these load balancers, and then you also want that auto scan for the backend. So you want to add more machines when appropriate, right? When the threshold has been kind of surpassed, and also not only that, it can scale up, right? But you also have a threshold for when, like, okay, our peak, usage is down. Now I have another CloudWatch threshold for when the CPU is below a certain level, right? So that will say, okay, let's take all those extra machines down because we don't need it, right? We don't have that demand anymore. So again, right, it goes both ways. You can scale up and scale down to save money and also keep your infrastructure a little more secure, right? Because the more resources you have out there, the bigger the attack vector. So that's just basically what I wanted to cover there. And then let's look at the app, right? Like, let's jump over to our deployment. And I did with Terraform, you can kind of tell the system to give you the end result, right? So nothing was all of these like load balancers and endpoints are kind of processed, right? And then at the end, nothing is predetermined, right? It's always like, here's your endpoint, and Terraform receives that information and pumps it out. So what we're going to do is just check on Kyle's cool app that he wrote, right? So here's the application running in ECS on Graviton 2 powered compute nodes or ECS instances that are in, or EC2 instances that are in my cluster. The reason why there's images that'll pop up. The reason why it's a little slow is it's in Heroku, the API that we're calling. So Heroku sleeps your assets if you're not using them, which is I'm totally down with that, right? To save power and some of the environment. But this is the app, right? So I don't want to focus too much on the actual app, although it's awesome, Kyle. You did a great job. We're here to talk about CI/CD pipelines and deploying things. But at the end of the day, right? So like, look, I just added some water. Looks great, right? Works cool. And I don't want that water no more.
It's because the database is.
No, it's my mouse. It was my mouse.
Oh.
Yeah, don't worry about it. I have an old mouse. See, I'll show it to you. See that?
Oh wow!
I know. Very, very colorful. I love this thing. It's like the best. It has my imprints.
It's got a wire. No, I'm
kidding. Yeah, man. Right? Hey, I'm always wired. But basically, right, you see it running. It's awesome, right? The deployment's there. And again, the focus is on, handling microservices in a mono repo context, as well as, right, using infrastructure as code to provision infrastructures. And also, the Docker images or artifacts, pushing them up to the different services. So there's a lot going on in this pipeline. And if we jump back over to it, I want to show you one of the cooler bits of the pipeline as well. So you can see, let's just jump in. I'm looking at this from a different angle here. So what you see here, right, is all those jobs that were like kind of listed, right? And this is kind of the clean way of showing you, visualizing that code that we, defined our pipeline in, or YAML. And right, I'm sure these are familiar: the front end test job, the build Docker image job, the deploy AWS ECS job. But like I said, right, we just need this to understand that, okay, it works. Normally this wouldn't even be here. Normally this would be replaced by like a smoke test, which would automatically call out to that endpoint, right, that I just went to, like to this application, and then, run some tests. Maybe you want to just test, hey, OK200, is the server responding okay? Yeah. Am I getting any 404s or 505s, right? Whatever you want to do in the form of a test, which I call a deployment test, is very valuable. Again, right, you're verifying or validating that this specific release and this code will function in the environments you're targeting. In this case, a Docker image on an ECS cluster. So what this is a manual, we call a manual step. Let me jump over to the code real quick and show you what that looks like, how you could define that. I think we showed that, but it's mainly in the workflow section, because remember, jobs are just defining the things that you want to do, right? In kind of a grouped manner, where workflows are orchestrating those jobs, right? Those things you want to do. So that's why we have a workflow called front end. And then, right, we have our little when statement. So that means, hey, do this when this thing is true, which is the pipeline dot parameters front end is true from over here, right? We kind of did that. And then there was some code changes. So it kicked off the jobs, right? So then you have a list of jobs that you want to orchestrate. And here you go, right? This is how the order. Now, the reason why those things kind of executed in parallel, by default, CircleCI just executes your jobs in parallel. If you need a dependency, like I did here, right, with the approve, I stopped it, right, because I don't want this job to continue without a manual intervention. But if you can also apply that require statement to build dependencies. Like, I know people are probably like, wait, he's testing and then building and then deploying on and building infrastructure at the same time. Don't you want to have some safeguards? Yes, you do. In this case, I don't really care, because my interest is in being fast, right? I like my jobs, these specific jobs, to be under a minute. None of these are doing that. But realistically, you're deploying to AWS, you have no control over that. But at the end of the day, yes, you want to build dependencies. So like, maybe there should be a front end test and Docker build image can happen at the same time. If either one of them fails, then don't deploy, right? Like, that's the kind of stuff you want to do. So let's go ahead and jump back over and look at the approval definition, right? I just wanted to cover this really, really quickly. But this app approve destroy job, right? You can actually create a job inside of the workflow and then give it a type approval, which tells the system to stop, right? And don't continue on, because it requires that this deploy AWS ECS job finishes. So, right, this one has to be complete before you can even access that button, right, to execute. And then finally, when you click that button, the next job here is destroy the cluster, right? And when that happens, guess what? We have another requirement, right? And it's not going to destroy anything unless this guy, the approve destroy button, right? So that's how you kind of chain those dependencies together. So let's go ahead and hit that button, and then we can take some questions, right, Kyle? I mean, I'm getting tired of hearing myself.
Yeah, we got a few coming in.
Cool. So
also,
I just clicked the button.
You got a small fan base growing.
I see some of my homies. I know some of those folks, and they're awesome people. So what up? So like, yeah, look at this destroy command. I think my mother's probably watching too. I told her to check it out. So hi, Mom, if you're watching. She usually writes something, so I'm not sure if she's watching, but I'm sure she'll say something. Yeah, she's my biggest fan. One of my biggest fans, anyway. So what we're doing here, right, is running that Terraform code to destroy all of that infrastructure. But it's going to take a minute because what we're doing is tearing down VPCs, we're tearing down networking, internet gateway. So there's a lot going on. And, in AWS's infrastructure, it's just a lot to tear down. And there's a lot of synchronization, right? So you can't just take down things willy-nilly, right? Like you can't take down everything at once. You can't just turn that switch off. You have to, decommission, deprovision resources. This would be no different if you were to have like your own infrastructure in a data center. You would have the same problems, right? Like you don't want to just pull the plug on everything all at once. It's not a great way to conduct business, especially when you're talking about provisioning, infrastructure. And you can see here, right? There's a lot of stuff happening, and it's happening rather quickly, right? But when that's all done, all of this will be gone. I'm sure our application is probably not functioning anymore. Let's give it a test. If I get redirected to Amazon's Amazon.com, then I know, right, everything's so it's tearing down, and we can check here. I'm not sure if so see the service is now gone. So it takes a little bit of time. I don't know if these things are still, they're still active. The instances obviously are still up then if that's working. But what will happen is all of this will go away, and you won't see this cluster business anymore. So let's talk.
That's pretty cool.
Yeah.
And sorry to cut you off. Like,
no,
kind of mentioning to your point, like, how long would this have taken if you were trying to set up this architecture from scratch by hand? Like having to basically keep a notebook of like all of these like commands and what order,
right?
Like that's just insane.
Yeah, prior to luckily, so I'm very happy that AWS took the API first approach, right, to all of their services, which is how I used to write Bash before Terraform and all that stuff came around. I don't want to show you, but I could show you all the old ugly Bash and Python scripts and even Erlang, right? Like, so I was writing Erlang scripts to accomplish this stuff because of the multi-concurrency. I really like that. So yeah, before that, but think about this though. If you had to create all of that in this dashboard alone, pointing and clicking, right, and typing, it's a nightmare.
Not to mention tearing it all down. That's even worse.
Yeah. So like being able to just, codify that infrastructure and provisioning it is just super, super efficient and helpful. And not only that, right, you have versions. So if something got jacked up in that whole process, guess what? I'm going to just go back a few versions and diff everything and say, all right, this is where, the error happened. And you can track that down like within minutes versus days like it used to take me. So, and I'm not kidding. I've been in this business a long time. So I've seen, a lot of cool things happen and a lot of really bad technology and really good technology. And I think we're on the cusp of, there's a lot of good technology out there these days. So yeah, see the app is dead right now. Let's jump in here. You can see things are like kind of spinning down. They're still up, but the load balancer is gone, which is why we're not seeing that anymore. So yeah, is there any other questions? I don't want to leave this here. Well, why don't we just leave it running so we can just watch it as it goes? Any questions? I see some.
Yeah,
oh wait,
so
that's you, Kyle.
I responded a few. We'll call them out anyway. So we got one here. Where'd it go? Here we go. The containers and microservices help with scalability of various amounts of features or users. And I think I get the core of what they're saying. But yeah, I mean, when we were talking about before, mix up these words, I know it might be confusing, but if you had a monolith app, which means, it's all one big thing, then you could not independently scale them. So in this particular example, I guess we kind of did it backwards in a realistic world. But in a realistic world, that API service in the back end will probably need to be scaled up larger than the front end, right? So there's no reason for us to spin up large machines that host both. What we would do is have maybe a small cluster for a front end. You might not even need a cluster for this particular front end. And then you can scale up the back end as necessary. So you can imagine if you had a lot of users on that front end all hitting the API, there's only a certain amount that back end service can take. So using this microservice architecture, we can scale that back end up.
Yeah, so don't focus in too much on like front end, back end is my advice in this demo, because what you just saw being applied to the front end can most certainly be applied to the back end, right? We just didn't do that because I figured this is a lot to cover and I wanted to make it simple and digestible. But like I said, we can come back and do some more complex, more realistic deployment type things if that's.
We figured the front end's more
something.
visual, right? So why not
Yeah.
go with the visual one? But the concept is exactly the same, absolutely.
Right. So like I just don't have the Terraform for the backend, but I can easily whip that up. And then you can even have like an ECS cluster for the backend, right? And then the front end and cluster and the backend cluster will, interact, right? So again, this is all just conceptual, but you can apply that same, matter of fact, that front end Terraform code. All you got to do is change the container and maybe tweak some naming in there, some of the variables, and then you're off and running with that backend running. I like to kind of give you a little sample of what to do. I like to edge and let people kind of learn to fish for themselves. So like this is a challenge. If someone does a pull request and creates the Terraform for the backends of this specific demo, then I will send you a swag bag from CircleCI. How's that? Can I do that on Braeden? Can I say that? Or like,
Yeah, that's perfect. Yeah.
All right, cool. Yeah. So some of the ways you can reach us is in our Discord channel. We have our server, I should say. So we have a CircleCI Discord server. So I don't know, Braeden, if you want to put that up, but
yeah.
Or did I supply that to you? I don't know if I gave
send
that
it
to
over
you.
to me and I can post it up.
Okay, yeah. I'm sorry about that. But yeah, we have a Discord server that you can reach out to. Kyle, you're on there too, right? So myself, Kyle, and the DevRel team for CircleCI is there. And yeah, it would be cool to see what folks kind of come up with. So yeah, fork that project and do that. While that's happening, I can see if I can pull that up. Or Kyle, if you can get that link.
Get the invite link? Yeah,
I think it's like here. Let me just type it in here. Yeah, if there's any other questions, I saw something here from I want to say what's up to my buddy Mastermind. He has a cool he does a lot of he's a very nice guy. He does a lot of free like education around DevOps, infrastructure as code. I know he's an AWS whiz, so if you get advice from him, it's solid. So I see here, hi, CircleCI, do you support mono repos or any other trigger of workflows outside of branch push? Oh, yeah. So, Kyle, you might want to help me out on this one. You can trigger jobs using the API.
Mm-hmm.
We are releasing a mechanism.
Sure if we're allowed to talk about that.
I'm going to.
Okay, all right.
I'm not saying when, but everybody's getting some insider information.
Yeah.
Marketing will kill me tomorrow, but that's okay. We are working on releasing some functionality to enable what you're asking for, which is, triggering these builds outside of a branch push. I don't know when that's going to happen. I don't know, where they are, and I won't speculate.
But exciting things are coming, whenever that is.
Yes. And I may have, tease. I'd rather tease it. I'm in DevRel. We can do that. So I'll take the hit. But yeah, so yes, to answer your question, William, we're working on stuff like that, features like that. So,
and then of course you can use dynamic fig like we're talking about today instead of workflows.
Yes, that's another. Yeah.
Really, you're going to end up using it anyway, even when we get additional triggering methods. The dynamic config is really the heart of that. And if you did join in, late, I would highly recommend checking out the VOD. I know the video is going up on the channel, right?
Yeah, that's right.
Yeah, and at the end of the day, right, like the main thing is that folks understand. Again, I think we're pretty much the deploy has kind of finished, so let's check on that infrastructure. But at the end of the day, this whole demo was to kind of demonstrate how to again use or at least incorporate microservices and execute your CI/CD pipelines around that paradigm, and also the mono repo support, right? So and by the way, we're not done, right? There's more things coming, more enhancements that will help developers implement these continuous delivery concepts and facilitate them using CircleCI. Because again, right, like all of this stuff is conceptual, DevOps, continuous delivery, right? These are concepts, practices, and principles, but they're not real until you add automation. And that's essentially what CircleCI does, is enables an easy implementation of automation for your continuous delivery practices and principles. And it helps ease that pain of having to manage infrastructure, unlike some of the other CI/CD tools out there, where you have to stand up infrastructure and handle all that.